All right, today we're going to talk about we're going to learn how to multiply binomials that has radicals. By the way, have we learned how to multiply binomials before?
Yes.
Yeah, of course we have. You guys remember we've done this many times. But now only difference is we have some radicals. That's the only difference. Okay, does that make sense? Okay, so let's first look at our first example. This first example is going to be really important. Take a look at this, even though it's pretty simple. I have two binomials that happens to have radical. 6 rad 11 times 6 plus rad 11 times 6 minus rad 11. So, do we know how to multiply binomials? You guys remember? We're going to multiply 6 times 6, then what? 6 times negative rad 11, and then rad 11 times 6, and rad 11 times negative rad 11. But, by the way, do you guys remember multiplying binomial that looks like this? What is this called? Yes? Thank you. You guys remember this? So you could actually do all that work, or just remember the pattern. Right? Remember A plus B times A minus B. What does that give you, guys? So you could actually multiply it out. Right? Remember? Or just use the form. Right? You guys remember this? So it's going to be something squared minus something squared, right? Okay, go ahead. Everybody try. I'll wait. See what you get. All right, so what is my A in this case? In other words, it's going to be something squared minus something else squared. Angel? 6. What is my B? Yes, Christina? Rad 11. So I just simply plug those in the parentheses, right? It's nice. And so what's the answer here when I do this? How about Spencer?
I got 36 minus 11.
Good. 36 minus 11. Did you all get 25? Yes. Very good. Easy enough. Now, if I forgot this pattern, if I don't remember this difference of square, could I have multiplied 6 times 6, 6 times rad 11, rad 11 times 6, and rad 11 times negative rad 11? Could I have done that? Do I get the same answer?
Yeah.
Okay, now, guys, when we do our homework tonight, I want you to, not just homework, but when we go into some other examples, I want you to remember this example. This example is really nice because, do you see any radicals as our answer? In our answer? What happened to all the radicals? We had some radicals before. Now what happened? They canceled out. Michael is right. Because if you were to multiply them out, not using the pattern, you would notice that the middle term, which will be 6 rad 11, you would have positive 6 rad 11 plus what? Negative 6 rad 11. They cancel out. You get the same exact ones. They cancel out. Isn't that nice? Look at my answer. My answer does not contain any radicals. This is going to be very helpful for us when you have something like this on your denominator. Okay, so keep that in mind. We're going to get to that. Okay, so anyway, let's move on to the next example. Now, here's an example, even though it's very simple, where people mess up the most. We got 6 plus rad 11 all to the second power. So we're squaring this. Can I square each of the term?
No.
Only? And get 6 times 6, which is 36, plus 11? Can I get, is the answer 36 plus 11? No, why not? What does this really mean? Jason?
6 plus rad 11 times 6 plus rad 11.
Very good. So this is what you get. Please don't just square each of the term and get it wrong. Okay, that's the mistake that people make. Right? Go ahead, everybody multiply this out, see what you get. You will note that, it won't simply just be 6 squared plus 11 squared. Right, 11 squared. Okay. Alright, so how many people got this when you multiply? 36 plus positive 6 rad 11 plus positive 6 rad 11 plus 11? Yes? So do you see how we get the middle term? They don't cancel out. Only time they cancel out is when we had like the difference of square type, right? When they look the same, when the two binomials look exactly the same, except one of them was addition, the other is subtraction. And so how many people got this as the answer? 47 plus 12 rad 11 as the answer. Raise your hand. Very good. Easy enough? Yeah. Can you do this then? If I have subtraction, does that change much? No. Okay, go ahead. Everybody try this. What if I have 6 minus rad 11, whole thing squared? Go ahead, everybody. Figure this out. Yeah, I'll move it up. Alright, so did you all write this as 6 minus rad 11 times 6 minus rad 11? Okay. So what did you get when you multiply this out? Did you all get this? This time it's same as before, except the middle terms are all negatives, right? How many people got the answer as 47 minus 12 rad 11? Okay, do you see how we get minus 12 rad 11, not plus? Before we had plus 12 rad 11, right? Does that make sense? Okay, please don't just square the two terms, right? Get 36 minus 11 or something. That'd be wrong. Please Remember that, right? You get the middle terms, right? You get square roots and so on. Okay, are we good? Let's move on to example 4 then. Let me give you something more interesting here. All right, example 5. Example 4, thank you. 5 rad 5 minus 2 rad 13. The whole thing to the second power. The whole quantity is now to the second power. Go ahead and, this time, both of the term contains radical. Does that change much?
It should.
Not much, okay? Go ahead and multiply this out, see what you get. It's the same exact thing. The other one, you only had one of the term having radical. This time, both of the terms have radicals, but it doesn't change too much. Go ahead and already multiply it out. I'll wait, okay? Yeah, it's 5 rad 5 minus 2 rad 13. The whole thing to the second power. Go ahead, everybody finish it up. I'll wait. All right, so did you all write this as 5 rad 5 minus 2 rad 13 times 5 rad 5 minus 2 rad 13?
Yes.
All right, somebody tell me what we get when we multiply this. Okay, how about, remember each of these terms has to multiply all together. So Chuck, what do I get here?
25 rad 25 minus 10 rad 65 minus 10 rad 65 plus 4 rad 13.
You got it. That's what I got. Okay, so 25 times 5 really. Rad 5 times rad 5 is 5, isn't that right? You see that? Okay. And at the end, how many people got this? Okay. Don't try to multiply this whole thing, right? In this step, because you may make silly mistakes. That's why I wrote down 5 times 5 is 5. Rad 5 times rad 5 is 5 here, right? And then you get 5 rad 5 times negative 2 rad 13 is negative 10 rad 65. The other same way. And then negative 2 times negative 2 is positive 4. And then rad 13 times rad 13 is 13. When you multiply this out, you should have gotten 125 minus 20 rad 65 plus 52. Yes? What's the answer? One person knows? Come on, we're all done. Patty?
177 minus 20 rad 65.
You got it. How many people got 177 minus 20 rad 65? Easy enough? Do you see where your mistake is? I'll give you time. Go ahead and fix your mistake. Help each other out, guys. If your teammate didn't get it, fix to help them. Now take a look at example 5. I got 6 over 3 minus 2 rad 3. And we're going to simplify this. You may say, wait a minute, isn't this already simplified? The answer is? Very good, very good. Okay, one person. Okay, who can tell me? Whole bunch. Raise your, Carolyn, how come this is not simplified?
Because you need to rationalize the denominator.
That's right. My denominator contains an irrational number. That's not good, right? That's not simplified. So, as before, could we just multiply top and bottom by rad 3?
Yes.
Actually, if you try this does not work. I put a big X here. The reason is because, yes, it will get rid of that rad 3, but yeah, it will create another rad 3 if you want to multiply it out. You see how I get 3 rad 3? You see what I mean? Okay, so it does get rid of that rad 3 on the second term, but it puts the rad 3 on the first term. It doesn't really help you too much. Now we still have radicals in the denominator, so that's not going to help us. Could we multiply the bottom one by the same denominator? 3 minus 2 rad 3. Okay, if you do this, it will not work either. Why not? Anybody see why it won't? You're going to have, look, okay, on the numerator you get 6 times 3 rad, okay, you can multiply that out, but look, when you do 3 minus 2 rad 3 times 3 minus 2 rad 3, will the middle term cancel out? No. So remember, exactly. So when you do this, guys, listen, you get 9 minus, yeah. Okay, hold on. 6 rad 3 minus 6 rad 3. Listen, plus 4 times 3, which is what? 12. You see how the middle term stays the same? So you still have radicals, right? 9 minus 12 rad 3 plus 12. So that's not, so yes, very good. You guys remember the difference of two squares? Guess what we have to do then? Instead of multiplying the same denominator, we got to multiply? Which one? Okay, everybody think about it. I'll wait. Go ahead, think about it as a team. What do you have to do? Do you see why we did example 1 in the very beginning? Look at example 1. Look at our answer to example 1. Did you have any radicals in there? No. So how did that happen, even though you had some radicals for the binomials? What do we have to multiply top and bottom of this by, guys?
Opposite.
Well, not really opposite, because the opposite will be negative 3 plus 2 rad 3. It's not really the opposite. It's the same exact binomial, except instead of subtraction, you need what? Addition. Do you see what we need? Because when you do this, then it becomes kind of like the difference of square, right? Multiplying the difference of square. You see, if you do this, your denominator will not have any radicals, right? Because what does it mean to multiply? How do you multiply these two binomials that look exactly like, but one of them is addition, the other is subtraction? It's going to be, yeah, it's a squared plus b squared. I mean, no, you don't get a squared plus b squared. What do you get?
Minus.
A squared minus b squared. It's something squared minus the other thing squared. So all the radicals will go away. Does that make sense? Because you're squaring them. Yes? Go ahead, everybody finish it up, see what you get. Okay, do you see how by multiplying that denominator that contains the binomial that has the radical, if you multiply the same binomial except instead of subtraction you need addition, you see how it's kind of like the difference of two squares? You get something like this, right? 9 squared minus 2 rad 3 squared. Now if you don't believe me, you can multiply it out on the side. Here's the work, right? Okay, so when you do this, right, don't we get 9 minus 12 on the bottom? You see how we don't have any radicals on the bottom? That's the key idea. So if you see a fraction with binomial having, on the denominator, if the denominator is binomial and if it has radicals in there, all you have to do is multiply that same binomial except it has to be opposite of what you had. If this was subtraction, you need addition here. If it was addition, you need a subtraction. Do you guys get that? Okay, so that the middle terms will cancel out, just like your example 1. Yes? And so we're done. How many people got 18 plus 12 rad 3 over negative 3? Yeah, you're not quite done. What can we do here? How do we simplify? Aaron?
You divide everything by 3.
Yes, you could divide each other term by negative 3, not 3. Or could we just factor out a negative 3? Isn't that the same thing? So if you were to factor out a negative 3, what do we get? It'll be negative 3 times, wouldn't it be negative 6 minus 4 rad 3? And what happens with negative 3 and negative 3 on the top and the bottom? They cancel out. How many people got negative 6 minus 4 rad 3? Very good. Okay, so go ahead and take, now, listen, class. All right, class. May I have your attention? Here, look. Also, could I have done this? 18 over negative 3 plus 12 rad 3 over negative 3. Could I have done it this way? Yeah, don't I still get the same answer if I did that? Because I noticed, listen, I noticed each of these factors, 18 and 12 rad 3, it contains a factor of 3, doesn't it? So I could do it this way also. But it's the same thing as factoring out a negative 3, right? And canceling it out. Any questions? Do you see how this works? Yes? That's the key idea. Okay? Let's see if we can do one more. Here we go. All right, here we go. Example 6. Everybody try. Listen, I got 6 minus 2 rad 3. Eric? Okay, we got 6 minus 2 rad 3 all over 3 rad 2 plus 3. This time, you have a binomial with radical on the numerator also, but it's not that different. Look at what we have on the bottom. We got 3 rad 2 plus 3. So how do we rationalize the denominator? This time it's a little bit different. What are we going to do? One person knows? Okay, how about, who haven't I called? Tajwar. What do I do?
By rad 2 plus 3.
No, not rad 2 plus 3.
Oh, sorry. Rad 2.
Rad 2?
What?
No.
I know.
Okay, Tajwar, look at the previous example.
Save you.
Sorry, that's what I meant. 3 rad 2 minus 3.
Minus 3 is exactly right. We need to be multiplying. By the way, we have a name for those. Okay, those two binomials that look exactly like, one of them is addition, the other is subtraction. And it's kind of long to say that, right? We have a name for that. It's called conjugates. So when we say, yeah, so the conjugates. Yeah. That's what they're called. The two binomials that looks exactly like, but one of them is addition, the other is subtraction. Okay? Conjugates. Okay, these are called conjugates. So if we refer to them as conjugates, you should know what we mean by this. Anyway, go ahead. Everybody multiply it out, see what you get. I'll wait. What are these two binomials called again? The ones that have the radicals in them, but then one of them is addition, the other is subtraction. They're called what? Conjugates, okay? Please, we like conjugates because that's how you rationalize the denominators. Yes?
Yes.
Okay. So when I multiply the numerator, somebody tell me what we get. How about who haven't I called today? I haven't called Samantha? Sammy, what'd you get for the numerator when you multiply them? Yeah. 18 rad 2 minus what? 18, good. Minus?
Minus 6 rad 6 minus 6.
Very good. But minus what? 6 rad 6 plus, it's negative times negative. Plus what?
Plus 6 rad 3.
Good. Be careful. The last one is plus, guys. One of them is the other subtract. I mean, one of them is negative. The other is negative also. So yes. No, it's okay for now. By the way, do we have any of them? Do we have any like terms on the numerator?
No.
No, we don't. Okay, so we can't really add them together, can we? What about on the bottom? What do we get on the denominator? How about Lynette? 9. Because you get something squared minus something squared. Well, your A is 3 rad 2. B is 3. So when you do that, you get 9, right? Because you get 18 minus 9, don't you? Very good. So I'm done, right? No. Do we have a common factor on the numerator and the denominator?
Yes.
What do we have a common factor of? 3. 6? 6 doesn't go into 9. 3. So go ahead and factor out a 3 from the numerator and cancel that out with a 9. Go ahead, everybody finish it up. I'll wait. Alright. Oops.
I got it.
Bella, what'd you get when you simplify this?
Yes.
I got 6 rad 2 minus 2 rad 6 plus 2 rad 3.
Correct. When you factor a 3 on the numerator, you get 6 rad 2 minus 6 minus 2 rad 6 plus 2 rad 3 all over 3. Any question? Can you do something like this for your homework tonight? Yes or no? Yes? If you didn't get it, go ahead and fix it. Wait, go ahead.